In this class we will continue our study on assemblies, learning how to insert constraints between components. The restrictions are very important because they allow us to define the actual conditions of movement of the set, analyze interference and much more. Let's go to class. Using the assembly we started in the previous class, we will enter the restrictions. In SolidWorks, we enter the constraints through the mate command, and as we add the constraints, the parts are positioned and the set updated. Therefore, there is no concern at the time of insertion of the components, as the definitive positioning is carried out later. We used as positioning reference the fixed component, in our case, the engine block. In this assembly, the engine block is fixed while the crankshaft rotates, moving the connecting rod and piston. We activate the kill command. Note the property manager. In the first box we select the entities that we will list. Below we choose one of the positioning options. By default, SolidWorks always suggests an option considering the entities we select. For entities we can select faces, planes, edges, vertices, axes, among others. We select the two faces shown. Note that the moving part has been positioned relative to the fixed part and that the floating bar is being displayed. By default SolidWorks applied the concentricity ratio, which is the desired constraint in this case. But if we wanted to apply another restriction, just click on its icon. We have confirmed, and note that the movement of this piece is now restricted, but not fully. To narrow it down completely, let's add another mate. We select the faces shown and apply the coincident relationship. See that now the only movement of this component is the spin. Now let's get the connecting rod in position. We select the faces shown and define the relation concentric. We select the other two faces and set it to coincident. Next, we will position the piston. We define a concentricity relationship between the faces shown. We define another concentricity relationship between the piston and the block. To complete the positioning, in the Advanced Mates tab, we select the width option to center one piece relative to the other. In the first box, we select the faces of the connecting rod, which will be centered relative to the piston. In the second box, we select the face of the piston. Confirmed and ready, our set is completely restricted, maintaining its functionality. See, we can turn the crankshaft and visualize the movement of the connecting rod and piston. We can edit the mates at any time because they are stored in the assembly. We finished this class, where we learn to apply mates, defining relationships between the components and simulating their actual assembly conditions.